going to talk about genetically modified organisms today, and a little bit of a background for how I came to learn about genetically modified organisms. Before I became a nutritionist and studied here at the Institute of Holistic Nutrition, I worked for an environmental group called Greenpeace. They're one of the largest environmental organizations in the world, and I worked for 4 years here for the Canadian office, and then had the opportunity to work for a year internationally. And they have a number of campaigns, and one of them is around sustainable agriculture. So we learned a lot about the different chemicals that we use in conventional agriculture, as well as genetically modified organisms, where they're being planted in the world, and some of the environmental and health ramifications of that. When I left Greenpeace, I got really interested in, if we don't need genetically modified organisms, what are the solutions? What are all our alternatives, and are they viable? Would they work? And so I studied for a few years different things like small-scale organic gardening, things like container gardening, rooftop gardening, aquaponics. I got my permaculture design certification and learned about systems where they're not seen as a closed loop, and how we can actually start to see things not as waste in a system, but as opportunities for reuse for something else. So we'll talk a little bit about what some of those solutions are today. First, we're going to talk about genetically modified organisms. Genetically modified organisms are not the same thing as selectively bred organisms. They have a different process. So we'll talk quickly about how they're actually created, and then because of that, what are some of the concerns for environmental reasons, and what are some of the concerns for our personal health reasons. So one thing that I often hear is confusion around what is something that's genetically modified and what is something that's selectively bred. So I work at a clinic in downtown Toronto, and we have a cafe downstairs. And one day I walked into the cafe, and one of the women who worked there picked up this massive beet. It was the size of a bowling ball. And she said, "Look at the size of this beet, GMO right here." And I thought, well, no, not exactly. We don't actually have to genetically modify something to make it really big. So I think sometimes when we see things and they are a certain characteristics, they're really big or they look a certain way, we assume that they've been modified to be that way, which is not necessarily true. We have a few chairs here too, so feel free to, yeah, go for it. Welcome. So one thing to know is that we have been traditionally farming and breeding crops to have characteristics, whether or not that be to be really big, whether that be to be able to withstand drought or cold. And that doesn't necessarily mean they've been genetically modified. They've just been bred to have certain characteristics. So one thing to be really clear on is a genetically modified organism is one where we have spliced its DNA. We've literally taken the genetics, so the genes of something else, be it another plant, a bacteria, it could be cells from a fungus, it could be cells from a human. We've taken cells from somewhere else, genetic information, and we've implanted it into that organism. Generally, this is done through a means called recombinant DNA transfer or gene splicing. So this wouldn't be a beet that's really, really big. This might be a beet that's been engineered to be able to withstand the application of herbicides, or it might have genes in it from a different species entirely. It might have genes in it from a corn plant. There's chairs in the corner. Feel free to grab some. Welcome. So this is a really big difference and something that we have to be clear on. So just because something has a certain characteristic doesn't necessarily mean it's been genetically modified. So the real issue with genetic modification, and where a lot of our concerns lie, is that we're crossing species boundaries, which is something that plants have never been able to do before. Generally, plants are only, and animals, are only able to cross their DNA through natural mechanisms. I'm not able to walk close to you and splatter out some of my DNA and then it splatters into you. That's generally not how things breed. So when we're talking about this, we're really crossing the ability of what nature can do. So that's some of the concern that we have. The most common two ways that we splice DNA now, so how we do gene splicing, is either by, there's chairs in the corner, feel free to grab some. The two main ways that we do it now is either by using bacterium. So there's bacteria that can carry in the genetic information that we want, and it moves into the DNA and moves into the genes of the organism that we're trying to splice, and it carries in the new information from the other species' genes. The other method that they use is something called a gold gene gun, which literally is kind of like what it sounds. It's a gun, and they use little particles of gold. They aim the gun at the organism they're trying to splice, and they shoot the gold particles with the pieces of gene that they want on it, and they hope that some of it goes into the right spot within the DNA of the organism, which doesn't always happen, because as I'm sure you know, DNA is very, very small. So sometimes it's imprecise. Sometimes they don't know if the bacteria has gone into the right spot. And if it doesn't go into the right spot on that DNA double helix, it might not display the characteristic properly. So what they often have to do is they use antibiotics as a way to test whether or not it's gone into the right place. So they, in addition to the genetic information that they're trying to splice in, they also add antibiotics. And so if it's gone into the right place and then they then douse it with antibiotics, the ones that have the antibiotic resistance input on them will survive the dousing of antibiotics, so they'll know that that splice has gone into the right spot. And the ones that don't survive the dousing of antibiotics, they'll know that it's gone into the wrong spot. So now we have crossing species boundaries, and we also have the use of things like bacterium going into something else's genetic. And then we also, feel free to grab one of the chairs, yeah. Or the big comfy one as well. Okay. Go for it. And then we also have this use of antibiotic-resistant markers at a microscopic atomic level, which is something that might be of concern as well. In terms of the history of GMOs, GMOs have been around for about 40 years. The first GM crop that we had on our grocery store shelves was called the flavr savr tomato. And it was a tomato that was bred to withstand cold temperatures. And they did this by putting fish genes into the tomato. Across the board, consumers didn't like it. They found the flavor was pretty bland. I don't think it actually tasted like fish by any means. It just wasn't a very tasty tomato. But it is something interesting to think about, that the very first crop that we made, if I have an allergy to fish, why wouldn't I think it was okay to buy a tomato? So interesting that we took something that was highly allergenic for lots of people and we put it into a different crop, which a little preview for some of the health concerns that I'll talk about later. The main uses so far that we've had for genetically modified organisms have by far across the board been in order to apply more herbicides, pesticides, and fungicides onto big crops. So when we look at how have we used the technology of genetic engineering or genetic modification, the vast majority has gone into creating crops that are herbicide and pesticide resistant, and I'll talk in a little bit more detail about what that means. There's more chairs as well, so feel free to. Up there? Yeah, or well, you can take the chair and set up wherever you like. Just kidding. Oh yeah, go for it. The big companies that we have who have pushed this creation of genetically modified crops that have been able to stand herbicides and pesticides, there might be some that we've heard of before. So show of hands, have we heard of Monsanto before? Monsanto is generally number one in terms of pushing herbicide-resistant and insecticide-resistant crops. We also have Syngenta. You heard of Syngenta before? It's the second biggest producer of genetically modified seeds, so they're a Swiss corporation that's around the world. We also have DuPont and Dow Chemical. Syngenta. Syngenta. Dow Chemical, DuPont, these are all some of the biggest producers of both the chemicals that are designed to be put on these genetically engineered crops and also the seeds for the genetically engineered crops themselves. One thing that's really important to note too in the history of genetically modified crops is it's the first time in the history of life as we know it that we have been able to cross species boundaries. So when we have created this technology where we're actually able to cross species boundaries, so fish and tomatoes don't generally get it on in nature, but we've somehow managed to splice them together and have this new fish tomato, right? Fish tomato, weird thing. So now we have this fish tomato. When we're deciding how do we treat this, should the fish tomato be treated exactly like a regular tomato? How many people say, yeah, same thing? Show of hands. Okay, good, I'm glad we're on the same page. So this is one of the things that I find particularly troubling with genetically modified foods. That when we were creating the legislation for how should we treat genetically modified foods, the resulting legislation essentially came up with something that says, if it looks like a tomato, tastes like a tomato, it's a tomato. And that's the way that genetically modified crops are seen. They're not treated as being fundamentally different from their natural cousins in nature. And when we look at who decided this legislation, so the first big deciders of this were the FDA in the United States. When the FDA was deciding the legislation that would determine how we treat genetically modified foods, the person in charge of the decision of the FDA at that time was a man named Michael Smith. Has anybody heard of Michael Smith before? A few of us. So Michael Smith happened to also be one of the head honchos at Monsanto. He left his post with Monsanto, took a job at the FDA at the time when they were deciding the legislation of genetically modified foods. Legislation was put into effect that genetically modified foods wouldn't be treated any differently. What do you think he did after that? You guys are right. Yeah. We're going to get along just fine. Exactly. He left the FDA, went back to Monsanto. I'm assuming he probably made a better salary at Monsanto. And we see this again and again and again. So Michael Smith has done this like round FDA, back to Monsanto, back to FDA when important legislation is being decided, back to Monsanto, several times throughout his career. And that, to me, shouldn't be allowed, because that clearly seems to be a conflict of interest. And he's not the only head honcho at either a chemical or another company that has significant investments in genetically modified organisms who's taken seats on governments in order to pass legislation. So that's one other thing that we should be aware of when we talk about the history of GMOs, is how we've decided whether or not they're safe from a government point of view hasn't always been an independent decision, and not a decision that was decided by scientists. GMOs today, so this is not a particularly great projector, but what we have here is at the bottom of the graph, 1970. So the first few countries to start growing genetically modified foods were Canada, the United States, and Argentina. The end of the graph here in circles, we have 2010. So now we also have Brazil and China and India as other countries that are growing genetically modified foods. And the numbers in circles are not so clear, so I'll tell you what they are. For the United States, we're now growing 70 million hectares of genetically modified crops. Here in Canada, we're growing somewhere around 25 million hectares of genetically modified crops. So we are among the biggest exporters of these crops, which also sometimes tells us a little bit about the stance of government in terms of what their view is on these crops, because we're one of the biggest worldwide producers of them. In Canada and the United States, we have no required labeling of genetically modified foods. So if I go and buy this tomato with fish genes, I won't know that this is a tomato with fish genes, because it looks like a tomato, smells like a tomato, it's just a tomato. So when we look at whether or not we're consuming these foods, by far, and I would say probably most likely every one of us in this room has eaten them at some point. The bulk of processed foods, so 90% of processed foods on grocery store shelves, contain genetically modified organisms in them. So I would say if you haven't been actively avoiding them, you've probably consumed them at some point, which for a lot of Canadians is a really big surprise that they're that prevalent. And one of the reasons why they're so prevalent is because they're in crops that tend to be in almost everything. So what are some of the crops that you know of that contain genetically modified ingredients? Yeah. Corn, wheat, soy. These are in almost every processed food that you can imagine. We turn corn into corn syrup. We turn corn into maltodextrin. We have soy being used as a filler and an emulsifier in almost everything. This winds up both in our crops that we end up creating for processed foods and cereal grains and all of that, but these also often turn into crops that we then feed things like chicken and livestock and even farmed salmon. So we sometimes are also indirectly eating these foods because we're eating the food that ate the crops as well. So we are generally consuming them at a fairly high amount here in Canada. In the United States, there's been a number of states that have had votes put forward for putting labels on genetically modified foods. The most recent states that have tried were California, Washington, and Vermont. In California, it was a really narrow loss. It almost got through. Monsanto spent millions of dollars to be able to defeat the bill. In the state of Washington, it was actually narrowly defeated. Monsanto spent $22 million to defeat the lawsuit. In the state of Vermont, they won. So in the state of Vermont, it was decided that genetically modified foods should be labeled. Any guesses for what Monsanto did in response?
They sued them.
They did sue them. Do you know what they sued them for? So the state of Vermont actually was sued by Monsanto. Get ready for this. I find this absolutely hilarious. Because it was it was a violation of their rights to free speech. Monsanto sued Vermont for violating their free speech rights. And this is something that we can watch in the courts now. So some really interesting legal decisions being made as well, in terms of our right to know what we're eating. The other thing that's really important, and one thing that I find particularly concerning with genetically modified foods, is because we've actually created these seeds, it couldn't happen in nature. It also means that the companies who make these seeds are able to patent them. Because it's something that isn't natural, they then own that seed. So if I create a genetically modified soy, if I create a genetically modified apple, this is no longer just something, a seed that's in nature that we all have equal access and rights to. They now own this. So in essence, they own life. And because this was decided to be okay, that we could own seeds, that we could own life, which is something that makes me uncomfortable in and of itself, we also then created this slippery slope of life could be patented. And so now we have a number of things that were almost patented. For example, Monsanto decided to try and patent the pink pig. And now everybody who owned that pink pig was supposed to pay royalties to Monsanto. They tried to go to India and patent the neem tree because they were the first people to go to the patent office with the neem tree DNA, which is ridiculous because the neem tree is something that's been used for hundreds of years in India as a natural remedy and as a natural product to help heal. So there's a lot of other slippery slope concerns, and another one that's particularly relevant as well is that we now also have the patenting of human cells. So one of the human cells that has been patented is cells for a particular type of breast cancer, cells for a particular type of colorectal cancer, which then means as soon as those patents went through and it was decided that that was okay, there was a number of labs in the United States and around the world that were working on breast cancer research that had to stop because they couldn't afford to pay the royalties to continue to do the research, which is something that also makes me a little bit uncomfortable, that somehow the ability to look at our own health conditions and to study how we can heal and how we can progress and how we can learn could somehow also have this monetary owning and value tied to it. When we look at seeds, 90% of genetically modified seeds are made and therefore owned by Monsanto. So they really are one of the biggest companies when we talk about genetically modified seeds. Of those seeds, 85% of genetically modified seeds have been modified to withstand chemicals. So this is another thing to consider. When we look at this technology, sometimes the argument is this technology could be used for really positive things. Maybe we can use it to find cures for diseases. Maybe we can use it to grow extra livers for ourselves one day as a tool for being able to extend life. But when we look at where is the bulk of it going now, where is the bulk of the money going now, where is the bulk of the research going, by far the vast majority of it is going towards being able to apply more pesticides, more herbicides to plants. And ultimately, where do those chemicals go? They go into the soil, eventually into the water, and then back into the ecosystem and everything that survives off soil and water, which is pretty much everything that lives. So there's two main types of way that they make crops be able to withstand insecticides and herbicides. And that's either one of two things. So there's something called Roundup ready crops. Have we heard of these before? We heard of Roundup before? Okay. So Roundup's like a weed killer. So with Roundup, what they do is they actually genetically engineer the seed to be able to withstand Roundup itself. So that if I have a bunch of crops, a bunch of plants growing here, and some of them have been engineered to be Roundup ready, it means that when I douse everything with Roundup, everything else will die except for the Roundup ready seeds. They have a natural tolerance to the Roundup itself. So before, when we were farming, you might have had a conventional farmer use something like an herbicide, like Roundup, and they would have been able to spray it before they planted their crop. So maybe they would go in early in the spring, spray off all the weeds that are starting to come up, and then they would plant their seeds. They couldn't then apply extra herbicide again too much, or they would also kill their crop. So there was a limitation on how much chemical can you actually put on. We now no longer have that limitation. So now you can drive through and you can put on Roundup multiple times during a growing season and not worry about killing the crop that you're growing. But that does have a lot of other environmental and social ramifications, which we'll look at in a moment. The main ingredient in Roundup is a chemical called glyphosate. Has anyone heard of glyphosate before? What context have you heard of glyphosate before?
To help with, I guess, which might contribute, I understand, to things like leaky gut. I've heard of it.
Absolutely. Absolutely. Thank you. Yes, so there is a lot of connection between our intake of genetically modified foods and things like leaky gut and impact on gut bacteria, which I'll talk about in a little bit more detail when we get to the health section. Glyphosate was actually just recently, in the past few weeks, condemned by the World Health Organization as being a possible human carcinogen. And this is of concern because this is the major ingredient in Roundup, which is the major way that we genetically engineer crops to be able to withstand more Roundup and therefore more glyphosate. The other way that we make genetically modified plants is through Bt. Bt is a soil bacterium, and this bacterium has the ability to go into an insect's stomach, and then it causes holes in the insect's stomach, so essentially its stomach kind of explodes and the bug dies. And so this is why we engineer these crops to be able to be insecticides. So we essentially engineer the seeds so that if a little bug tries to eat it, its stomach's going to explode. And then we eat that crop. So then we start to wonder, why is there a connection between something that on a genetic level makes stomach cells explode and then perhaps the increase in things like leaky gut for us in our population? So it seems to me that if it makes a little insect's gut explode, that maybe it might do something to my stomach as well. In terms of some of the future application for genetically modified organism, we have a number of animals that are being tested for genetic modification. So we're testing pigs, cows. The image that you see on the right is a genetically modified salmon, which has been approved. So this is one that's actually being manufactured in the east coast of Canada. It's then being shipped down to Panama for further growing, and then it's being sent back to the United States. So what you see in the foreground is a normal farm salmon, and in the background is the genetically modified salmon at the same age. So both the fish in the photos are 18 months old. So you can see that the one in the front, it's 13 inches, the one in the back is 24 inches. So it's been engineered to grow faster. This is obviously of a little bit of a concern because if this fish escapes out into open waters and then breeds with other fish, it could pass on these genetically modified traits. So as soon as we start genetically engineering animals, animals can go out and breed, and that creates a whole new set of concerns. We have human cells being genetically engineered and also patented and owned. We also have the application of genetically modified meat proteins being studied, where we're not actually genetically engineering the whole animal, but we're just culturing meat protein in petri dishes. And there's actually certain environmental groups, like People for the Ethical Treatment of Animals, who are actually in favor of this type of genetic engineering because it means that we wouldn't be killing animals. So we might someday in the future see engineered meat protein, which if anybody here is a fan of Margaret Atwood, she's written some interesting books on this, and I would highly recommend some of her books on this. The other one that I find particularly concerning is something called pharmacrops, where we're actually engineering crops to manufacture pharmaceuticals. And one of the biggest tests that they've done is for the production of insulin. So we do not have enough insulin being made as quickly as we need it. And I'm sure many of us in this room have heard of issues with blood sugar regulation, increasing rates of diabetes, hypoglycemia, faulty blood sugar metabolism. And so how they're sometimes now testing different genetically modified crops is actually having crops like corn, which while they're growing make insulin. And then you can process the corn and remove the insulin, which to me seems particularly problematic because one of the things that we've seen again and again and again with genetically modified foods is they might make a crop and say, oh, this is only meant for animal consumption. Humans will never eat this. But then there's always shipments that go to the wrong place. And we have examples like Starlink corn that was only meant to be pig feed that ended up being in tacos in the United States. So what happens, and this is a big what if, but it makes me particularly concerned that one day somebody could be eating a bowl of cornflakes and there might be a dose of insulin in there. And the other thing that's a little bit concerning is crops like corn have a big open pollination. So when we're testing these field crops, they tend to not grow them in a laboratory all covered up and very well isolated from everything else. Sometimes they just have a little row cover of trees and cross their fingers. And when we're talking about pollen that can move for kilometers and kilometers on the wind or who might be carried by pollinators, there's a real concern that is there the ability for some of this genetic material to end up being crossbred with our native strains. In terms of the genetically modified foods that we have here in Canada now, we grow some modified foods and then we also import other foods. The big foods that we grow here is corn. So we grow a Bt corn, so that's that soil bacterium again that makes insects' stomachs explode. We make millions of hectares of corn, and we have found that thousands and thousands of tons of this corn that's meant for animal feed ends up going into the human supply chain. We don't create any sweet corn here in Canada. We don't grow it, but the United States does. So this is something that you might see if you're buying sweet corn from the United States. So they do have genetically modified in the States. Two big crops that we grow a lot of is soy and canola. These are generally Roundup ready crops. And one of the things that's often, I would say, used to promote Roundup ready crops is that you'll overall need to use less herbicide as a farmer if you use it. Because the plant itself can withstand herbicide and because you can spray it easily, you won't need to use it as much, you won't need to monitor as much. But what we actually see is we often find that farmers need to use more herbicide, not less. And one of the reasons is because they can. So they don't have to worry about killing the crop. So when they do have weeds popping up, it's easy for them to go through and apply more herbicide if they want without actually damaging their crop. But the other thing that we'll see, and we'll talk about this when we get to the environmental section, is because we're using more and more herbicide, we're actually creating something called super weeds. Has anybody heard of super weeds before? Okay, to a few of us. Super weeds are weeds that have become tolerant to Roundup and herbicide. So just like when we take, say, an antibiotic, we have certain bacteria that might become resistant to that antibiotic. And so we have bacteria that have antibiotic resistance. Plants in the same way, some plants naturally become resistant to the herbicide. So you can spray as much Roundup as you want on them and they will survive. And that's not a good thing, because then these weeds can proliferate. And we actually have stories in the prairies of Canada for giant amounts of like ragweed that grow so tall that they can actually destroy a combine if a combine is trying to move through a field. So there are these massive weeds with these massive root systems that then become really tricky to deal with because you can't kill them anymore with an herbicide. We've now created 8 types of weeds in Canada that are herbicide resistant. And around the world, we've created over 30. So these are becoming a really, really big problem for farming. We also here in Canada make sugar beets, and we turn the beets into sugar. So we have some types of refined sugars and other forms of sugars that contain genetically modified sugar beet in them. Beets, like corn, are also an open pollination, so they're ones that are of a particular concern because it's quite easy for their pollen to move, and therefore other beet species to be able to mix their genetic material fairly easily. The foods that we import that contain genetically engineered ingredients would be things like dairy. So in the United States, about 1/5 of cows are injected with recombinant bovine growth hormone, or RBGH. So when we're importing things like butters and ice creams and yogurts, this could contain dairy that's come from genetically modified cows. Vegetable oil is another one where you might find lots of genetically modified ingredients. So that might be because they're using the soy, corn, canola, or cottonseed oil in the generic vegetable oil. So that would be another one to look for. It's also one that I find you might often be exposed to if you're eating out in restaurants, that they're often using cheaper, large amounts of bulk vegetable oil. So it might be another source of exposure. In Hawaii, they're growing genetically engineered papaya. So if you're buying papaya that's come from Hawaii, there's a chance that it's genetically modified. And then in the United States, they grow some versions of squash, predominantly crookneck squash, and it's been genetically modified. There's currently no genetically modified potatoes in Canada. They failed, but we do now have another form of genetically modified potato that may be being planted in the United States. So there is a chance that if that one's coming up available again, that Canada might import that. So it's another one to look out for. And again, potato starch ends up being in a lot of processed foods. Another big one is cottonseed oil. So cottonseed oil is not one that I would recommend in general. It's not a particularly healthy oil to consume. It does end up being in a lot of processed foods and a lot of junk foods as a cheaper oil. And one that we often don't think about when we're talking about genetically modified organisms, but we talk about it a lot at the Institute of Holistic Nutrition, is that it ends up being in some vitamin supplements. And one of the big places to look for is vitamin E, which might be coming from genetically modified soy. We might have lecithin, which is a supplement that might be coming from genetically modified soy. And we have a whopping 80% of vitamin C supplements on the market coming from China. And some of them are being made off of corn, so the sugar from corn, which often is genetically modified. So it's one to look out for as well, that the vitamins that you're purchasing might also contain genetically modified organisms, which is often a place where we don't look for them. So I always feel like yes, question.
I'm sorry, on the previous slide, you mentioned dairy.
Mm-hmm.
Right? So all the dairy that's in Canada, is it all imported from the US and they all might contain GMO, or do we have like our own dairy from Canada that's not impacted?
Yeah, great question. So the question is, the dairy that we have in Canada, is most of it coming from the United States, and that is coming from the US, is it necessarily genetically modified? Most of the dairy that is in grocery store shelves does come from Canadian cows, which means that they don't have the bovine growth hormone. That's not allowed in Canada, so that's something that was regulated a number of years ago. However, what we do have is in most commercial dairy operations, cows aren't allowed to eat what cows are supposed to eat, which is grasses. We generally feed cows things like corn. We might feed them soy. And so those might be genetically modified. So you might be eating dairy, or you might be eating the meat from a cow that's been fed off of genetically modified food. So indirectly, it's consumed them. From the United States, it's about 1/5 of cows that have the bovine growth hormone. So what you can do, and we'll show you a few different tools for looking at how do you know. So how do you know if a product from the United States contains genetically modified ingredients, and how do you know if it doesn't? So at this point, you would have to know whether or not the specific company that you were buying it from. So I'm not familiar with US brands of dairy, ice cream. Anybody? Land O'Lakes, is that a US one? Yeah. Land O'Lakes. So we would have to look up Land O'Lakes and see whether or not the dairy, so whether or not the milk that they use as a material to turn into butter came from cows that had bovine growth, or whether or not they were using it from cows that were non-GMO. But then we'd also want to ask that extra question, what were those cows fed? So even if they weren't engineered to have the bovine growth, did they eat genetically modified corn? So there's a little bit further that we could go when we're talking about something that might eat genetically modified crops. I like to play devil's advocate. So pros of genetically modified organisms. It's a little bit of a stretch for me, I'll be honest. I think when we talk about the pros of genetically modified foods, where we might see applications would be things like perhaps health. So we now have 40% of Canadians with fatty liver disease. That's not good. The liver does a whole lot for your body. We want well-functioning livers. Is there a possibility that one day we might be able to genetically modify your own liver cells to reproduce and culture a whole new liver for you? Perhaps. Is that something that's good? Maybe, I don't know. I'm not saying that we shouldn't at all explore the potential of genetic modification, but what I don't like about it is that for now, the bulk of genetic modification isn't being done with something that's called the precautionary principle. Has anybody heard of the precautionary principle before? No, and I wish we all had, because I think it's so important. The precautionary principle essentially is the idea that if we're creating something new, the onus is on us as the creators to prove that it is safe before we release it into the general environment. And this is not the way we operate. Right now, we're creating genetically modified foods. We're pretending that if it looks like a tomato and it tastes like a tomato, it's a tomato. We're not treating them any differently. And then we're essentially all consuming them because they're part of the general environment now. And now the onus is on us as the population in that general environment to then go back and say, hey, wait a minute, I think we're getting sick. So we then have to prove that it's not healthy to then force them to take it out. And I don't think that's the way that we should operate, especially not when we're taking technology so far that we're doing things that nature can't on its own. That seems to me like something so special that we should be extra cautious first, and that we should study it first to make sure that it's safe. Are there potential pros of GM foods or genetically modified crops or organisms? Maybe. But I think we need to be really careful first, and I think we need to test them a whole lot before we consider introducing them into the general public and into the general ecosystem before we play around with them anymore. Does anybody else have any pros that they can think of with genetically modified food?
So then stem cell technology and cloning, that's all genetic modification, I suppose.
Well, we're playing with genetics, but it depends a little bit. Sometimes if we're just doing tests on genes, it doesn't necessarily mean that we're modifying them per se. With genetic modification, really there is the application that we're changing genetics. So with genetically modified crops, we're actually introducing the genes from something else into a different species. So we're crossing those boundaries created by nature, as opposed to sometimes we're just stimulating cells to replicate, which might be genetic manipulation, but it's not necessarily gene splicing in the same way. So there's different applications, and maybe some of them seem a little bit more natural or closer to nature than ones that are really jumping across species boundaries, which is something that can't be done. We'll look at some of the myths around genetically modified foods too, in terms of some of the arguments that have been made for why we need genetic modification and why we can't go back and get rid of them. So some of those are that we need genetically engineered crops to feed the world. So we have a growing population of people. What do we have now? Over 7 billion people on the planet, is that right? Heading towards 8 billion. Really big argument is that we need genetically modified crops because we wouldn't be able to grow enough food without them for all of the people who need to eat on the planet now. We often are told that genetically engineered crops have higher yields, so they're able to produce more than their native or their natural or organic counterparts. We sometimes hear that we can no longer grow crops without the chemicals. So if we weren't able to apply herbicides, weeds would take over. If we weren't able to apply the insecticides, then we wouldn't have any crops because the bugs would eat all of the crops and there would be none left for us. So that's a really big argument for genetically modified organisms. And then one that is often out there is that genetically modified organisms are safe, that we've never been able to conclusively produce scientific research that shows that they're harmful, therefore we shouldn't be concerned about eating them. And I would say those are probably the biggest myths that we see.
This is a question about genetic splicing versus modification. So seedless fruits that we regularly consume, is that modification or is that completely a different gene that's in the watermelon or the oranges and things like that?
Yeah, so there is a lot of technology. So the question was around the genetic modification versus genetic splicing, and we also can produce lots of interesting hybrids. So we have things like a grapple, and sometimes, or seedless watermelon. So how do we do that? So there is sometimes the ability to selectively breed. So let's say I have a tomato that did really, really well with this cold spring that started. I might save some of those seeds, and I might plant those seeds again when I know that we're going to have a cold spring coming. So sometimes we're just saving seeds for particular characteristics. I might selectively breed seeds. So let's say that I have a tomato that did really well in a cold spring, and then another tomato, and it produced this really tasty red fruit that didn't crack on me. So I might let those two tomatoes breed. I might even take a little brush out there, take the pollen from one and put it on the flowers of another. And then if I get a tomato that did really good in the cold and produced this tasty fruit that didn't split, I'm going to save those seeds, and I've been able to cross those traits that I wanted. We also have in the laboratory the ability to selectively pick those traits that we want, but they're still generally within species boundaries. So they're not necessarily taking, say, the genes of a scorpion and putting them into corn, or taking spider genes and putting them into a goat, which are, by the way, real examples. I'm not making that up. So that's where I would say that there's a really big difference in terms of we can still create lots of really fantastic things looking at technology, and we can make crops that are going to be able to be productive even with the changing climate that we have without necessarily needing to resort to crossing species that couldn't naturally. Any other GMO myths that I haven't put up here that people have heard?
I'm just curious, you were saying that because we feed genetically modified grains and foods to cows or animals, that affects the meat. I kind of thought, well, if we consume that, does that not change our genes as well? And then our future offsprings may develop a hybrid?
Yeah, so the question is, if we're eating something that's 8 genetically modified seeds, is there the potential for us to pick up some of those genetic variants and then pass that on? And I wish we had answers for that, and I wish this was something that we were doing research on. But this is also where it gets particularly problematic, and who is funding the research and who is paying for this research. And by and large, the most research that's being done right now on genetically modified foods is by the companies that produce genetically modified foods. Generally, they're only displaying results. They're not actually providing access to the raw data, which is also another thing that's particularly problematic. The few independent labs and scientists that we've had that have done studies on this have been widely condemned by pro-GM companies, and really sometimes their reputations have just been dragged through the mud. So I do think there's also a little bit of a culture of fear around even engaging in research like this. And the one thing that is absolutely true and very unfortunate is we have no long-term study yet of the ramifications of eating genetically modified foods for a number of years, or what it does over lifespans. So I'll talk a little bit about what we have found from the limited data that we have, which seems a little bit concerning or something that we should maybe be cautious about, but there isn't a study that I can point you towards because we haven't actually done one, which I think is then maybe something for us to think about pushing. Shouldn't we push the government to do a study like that? Because I want to see the data from that. I want to know that. I want to make an informed decision about whether or not I eat it and whether or not I feed it to my children.
Because I've actually seen those very large cows down in South America. They're enormous. And so when I would think if there's a growth hormone in that and I consume that, somehow that chemical is going to start interacting with my DNA.
Absolutely, absolutely. So whether or not the chemicals would be interacting with our DNAs, there's also, I think, the interesting question too of if the bulk of the way that they are able to determine whether or not a trait took is by using antibiotic resistance at a molecular level. That means that you at a molecular level are consuming antibiotic resistance. So is that something that's contributing to why we're developing that as a culture? That's also something that we haven't explored yet with research. So some things that we do know from some of the studies that have been done. So the Union of Concerned Scientists compiled a peer-reviewed study. And it's one of the only really long-term studies that looked at a number of different research and report and made comparisons. And they found that that traditional farming methods outperformed genetic modification and genetically modified crops. So there was very few crops where the genetically modified crops actually produced a higher yield, and that was generally negated by the fact that the farmer had to spend so much more money on the pesticides and so much more money on the seed. So when we look at do we need genetically modified crops in terms of the increase in droughts and the changing weather patterns that we have, it actually seems like by doing smaller scale traditional farming, we're more easily able to adapt, and that diversity that we have and the natural strength of our plants are more able to deal with that than the genetically modified versions. The United Nations Environmental Program conducted a multi-year study in Africa, and they found that agroecological, so that could mean small scale or organic or small scale traditional, outperformed conventional methods and increased food security in communities. So what that generally means as well is when we have small scale diverse agriculture, if you have 1 year where there's a particularly bad change in climate, or you have a particularly high amount of a certain insect, if you're just growing one monoculture crop, that could be really bad news if that crop doesn't do well. But if you have more diversity in how you're planting, it means you also have more food security and more resilience in your community, because if your cassava doesn't do that well that year, you have 15 other types of crops that you also planted, so you have backups. So it also tends to mean that the communities themselves are more vibrant and they're more able to adapt and they're stronger and more resilient. It also, in terms of food security, means that if you sign a contract with one of these seed companies and the next year they decide to tell you the cost of seed has gone up and so does the cost of that Roundup that goes with the seed, you're not as vulnerable to that because you're not signed on for a multi-year contract with this company. You have more ability to be able to do what you want. Your hands are less tied. The Institute for Responsible Technology and numerous other environmental and agriculture-based organizations, year after year after year, find the same thing. The supposed myth that we're not producing as much food as we need to feed everybody is a myth. Year after year after year, we produce more food than we need to feed the planet. The problem is not that we don't make enough food, the problem is we don't distribute it fairly. And here in Canada, we're particularly bad at this. So somewhere around a third of what we buy ends up going in the garbage bin. So this is something where a lot of work can be done to make sure that we actually just distribute that food a little bit better, because it's a falsity that we need to create genetically modified organisms or even have mass large-scale monoculture farming to feed the world. That's not true. One of my environmental crushes, such a great guy, David Suzuki. So David Suzuki, he's an environmentalist, prominent Canadian environmentalist. Who else wishes that David Suzuki would have run for prime minister? And it's like, God, boy. So David Suzuki, for those of you who used to be the nature of things nerds, might know that he was a geneticist. So as a geneticist, I really trust his scientific opinion on this. And he says, and I quote, "Any scientist who tells you they know that GMOs are safe and not to worry about it is either ignorant of the history of science or is deliberately lying. Nobody knows what the long-term effect will be." I'm going to talk a little bit about some of the social and then the environmental and the health implications of genetically modified foods. Of the social impacts of genetically modified foods, and this is not an exhaustive list, it's just ones that I think are particularly concerning, is that we have these giant seed companies, which are often also giant chemical companies that are dictating the way that the world farms. And that makes me uncomfortable, because if your bottom line is being able to sell more of the chemicals that go with your genetically modified seeds, that doesn't make me comfortable. We also have the loss of seed varieties and the loss of biodiversity. And again, loss of biodiversity weakens us. The health of an ecosystem is really reliant on the biodiversity of species that exist within it. And the more that we have these monocultures, the more vulnerable we are to the threats of changing climate, to the threats of insects, to the threats of other plants that might compete for those same resources. So we have more strength when we're more biodiverse. And right now, the bulk of our food around the world is coming down to about 12 types of plants. So things like millet and soy and canola and corn and wheat, these big global mega crops are providing the bulk of our calories, as opposed to the crazy biodiversity that we naturally would have had. So we also see increases in things like vitamin and mineral deficiencies, because we're not eating the variety of foods, but also because we're doing this big monoculture farming, we're depleting the soil. And so we have soil depletion and less actual goodness, less nutrients in the crops that we are producing. So we have a real loss of biodiversity, which is really important. We also have a control of seed supply in relatively small hands. So Monsanto and Syngenta own 54% of the seed supply of the world. Two companies own more than half of the seeds in the world. Does that make anybody else incredibly uncomfortable? That to me is mind-boggling. Seeds are life. Not only do we have only two interests controlling more than half the seeds, these two interests are also some of the massive, big chemical producers in the world. They're the ones who brought us things like Agent Orange, DDT, DEET. These are big, crazy chemicals that have done a lot of harm. And I don't feel very comfortable that these are the same companies that are controlling life and controlling seeds. The other thing that's, of course, really uncomfortable, and we've already mentioned this, is that when these seeds are genetically modified or engineered, they then own seeds. They've patented life. And that seems to be something that we should not ever have allowed. A seed should be owned by everyone. It should be owned by you and me. It should be owned by nature itself. It is not a commodity. It is something that we need to survive. It's like air or water. And corporations have tried to own water. Does anybody remember Bolivia? Yeah, we should not allow the resources that we need to survive to be owned by a corporate interest. That is not, in my books, okay. And I hope you're on the same page with me. Show of hands. Okay, restores my faith in the world. The other thing I think that's really problematic too is when we have these few corporate interests that control the seeds, they can also control the costs of those seeds. So then what happens to small farmers or larger farmers when every year they might have an increase in what they have to pay? And we really start to see the decline of small farmers and the loss of our farming populations. And we still right now, at this point in the world, have over half of the citizens of our planet being farmers. And we want that because they feed us, and we want to support these farmers. And the more these corporations end up impacting the ability of farmers to do what they do, the more that impacts all of us. We also sometimes see the collapse of local economies when genetically modified seeds fail. So we have had a number of examples in the past, things like BT cotton in India, where farmers signed on to contracts to grow cotton that was supposed to be able to withstand a particularly bothersome insect that would devastate cotton fields. And then that cotton didn't work out. And you had all of these farmers that put all of their faith in this type of BT engineered cotton, and then it failed. And so we saw a lot of farmers end up losing their livelihood and losing their farms because they weren't able to pay for the contracts that they had signed with companies like Monsanto. So we see that entire communities can be impacted, and that ripples out.
There's mass suicide.
Yes.
Over 200,000 farmers have committed suicide.
Absolutely. So the comment was that we have over 200,000 suicides by farmers in India. There's a woman named Vandana Shiva. She's an advocate for non-GMOs, and she's spoken a lot about the plight of farmers in India and the need for caution around genetic engineering. And there's a number of really horrific examples in India of farmers protesting by drinking the Roundup to make a social statement about the impact of Monsanto. So there's some real devastating stories around the world of things that have happened to communities. And I think one of the things that we need to do is to become aware of this, to become aware of not just what's happening in our own grocery stores and in our own markets, but what's happening around the world. Because when we support these companies, we support what they do everywhere. The environmental impacts, one thing that's particularly problematic with genetically modified crops is that they encourage large-scale monoculture farming. So you plant a whole bunch of your Roundup ready seeds in a big field, and then it's really easy to take your big machine and drive over it and spray the Roundup on everything. And it encourages this mass monoculture farming, which again contributes to a loss of biodiversity. It encourages the use of more chemicals and pesticides, which ultimately end up going into the ecosystem. But it also ends up depleting our soil. So if you have this massive amount of wheat, this massive amount of corn, and you're growing it and growing it and growing it, those plants are going to pull the nutrients that they need out of the soil again and again with each time that you grow it. And then you're going to need to put on artificial synthetic fertilizers. That can create things like nitrogen runoff, which can create things like algae bloom downstream. We have things like depletion. So when we look at what a bowl of spinach would have had in 1950 compared to today, you would need to eat 30 bowls of spinach to get the same amount of iron out of it. Has anybody here tried to eat 30 bowls of spinach for lunch? It is really intense. So you can't. So we start to see nutrient depletion because ultimately how full of what we need those plants to be is dependent on the health of the soil. And so with this large-scale monoculture forming, we deplete our soil, and that's not good because that's where our nutrients come from.
So in your opinion, how close would organic farming be to that spinach that you said we could have got all that nutrient out of in 1950?
Mm-hmm.
Would you say they're equivalent, or organic farming is also depleted?
So the question was, how does organic farming compare? Definitely within organic farming, there is a mandate that you are taking care of soil. So you have to replenish your soil, and that is one of the main driving philosophies of organic farming. So absolutely, we're going to see higher nutrient status in organic compared to conventional crops and foods that we grow. When we look at what it would have had back in, say, the 1950s, we still sometimes see, depending on the crop, that it's less even with organic farming. because there's just a certain amount of depletion that we're still having to try and negate. And there's lots of really fantastic ways that we can do that naturally, using things like seaweed foliar sprays or making things like compost teas out of nettle and comfrey. There's all kinds of really great tools that we can use naturally to start to replenish our soil. And one of my absolute favorites is to actually use the things that we generally are trying to kill for their nutrition. So who knows some of the foods that are absolute superfoods in terms of nutrition? Dandelions. What else? Nettles, wild foods, the weeds. The reason the weeds are that they're able to grow remarkably well in often very disturbed and often very depleted soil, because their root systems go down so far and they're able to pull and draw out what they need. So if we were to compare, say, that conventional spinach or even organic spinach to that spinach of 50 years ago, it might be less. But if we were to compare that to wild spinach, also known as lamb's quarter, only need a few leaves of lamb's quarter to get your reckoned amount of iron and magnesium and calcium in a day. So sometimes those very things that we're trying to kill with the Roundup would actually be better off in your salad bowl, but that's a whole other talk. There's also some concern around genetic pollution, in that what happens when we have a crop like corn or beet, and it's an open pollination, especially something where an insect might carry the pollen and take it far away. And is there the possibility that some of that genetic pollution or that genetic modification would then be able to cross with native varieties? And there's been a number of studies that have looked at corn in Mexico and have found that when they test the native strains of corn, that they're seeing some genetic modified traces within those native varieties of corn. So there does seem to be some type of genetic pollution happening in nature. The terminator genes and pharma genes are particularly worrisome. So the pharma genes would be those pharmaceutical crops, so corn that's producing insulin. Terminator genes, has anyone heard of a terminator seed before? So a few of us. So because companies that produce genetically modified seeds own the seeds, they've patented them, they don't want you to save the seeds. And actually written within the contract that you would sign with them, you're not allowed to save your seed. You have to buy it every year because we own it. You can't just save it and replant it. It's ours. You know, I can't think of like an example with a t-shirt. It's like buying a brand t-shirt and then copying the brand and selling it as the brand. You can't do that. It's theirs. They own it. And because they are concerned that farmers might be able to do that, save a little bit of their seeds and plant it again, which farmers did for millennia, because that's how we grew food, they've started something called, we call it terminator technology, where the seeds are sterile after one life cycle. So for example, if we were talking about canola, the canola would grow for one life cycle, and then if you were to plant the seeds from that crop, they wouldn't grow because the seeds are sterile. And it's a way to make sure that farmers don't save seeds. So if that was a form of genetic pollution that could then cross with natural varieties, that is incredibly frightening. We don't want that getting out, and we don't want that out in nature. And we have tested field trials of this that are out in the open, again, not using the precautionary principle. So that's, again, something that's of large concern. So we've got the super weeds, and these are really big issues for farmers. Yeah, question? Ooh, big question. So the question was, if we're eating foods that have sterility placed into them, could that affect us and eventually lead to our infertility? Again, it's not something that has been studied yet, to my knowledge. Yeah. And then one of the largest environmental impacts, and I think this is a really good argument, whether or not you're anti or pro-GMO, the use of GMOs has not led to less chemical. It's led to the more higher and higher and higher amounts of chemicals that we use. And ultimately, those chemicals go into the soil and then into the water, and then we consume those chemicals again. And that's a really big concern because it affects not only us, but also everything else in the ecosystem. So we have here, between 1994 and 2010, herbicide sales in Canada rose by 130%. That's a lot of chemicals that we're putting into our ecosystem. The impacts of some of that, when we're spraying chemicals on the ground, that imbalances all of the little life that supports the soil. So things like nematodes and protozoa and soil bacteria and earthworms and microarthropods, all these cool little critters that keep soil healthy, which if you've got a garden and you've been planting some stuff, you probably see them all skitter away when you're planting stuff. Those are guys that really keep the soil healthy, and through their poo and through them eating other things that live in the soil, they remineralize the soil for you. They make the soil healthy, so we don't want to kill all of those off. When we kill bugs indiscriminately as well, we also kill the good bugs. So things like ladybugs eat aphids. So some of the bugs that we kill inadvertently would have helped to control the insects that were eating our crops. So we kill beneficial insects as well. And then of course, the bugs that we're killing are also food for somebody else. So things like amphibious species, spiders, birds. We're seeing a decline in birds and our native songbirds that is absolutely depressing. And most of those birds will have eaten off of these bugs. And so it's not just what are the chemicals doing to the crop, it's also taking a step back and how does that impact everything else that lives off the bugs and that exists in that ecosystem. We in Canada, when we're also trying to get rid of some of those weeds, what a farmer might consider a weed, so something like milkweed, is actually food for other insects. So monarch butterflies use milkweed as food, and we've seen a decline in monarch butterflies that's 90%. So we end up killing food for really beneficial things. Also our pollinators. So we're seeing declines in bee species, dragonflies, and other species who would have done pollination for us, which is also a concern because we need our pollinators. If not, we're all going to be out there all night long with brushes doing the work. And then I think the other big thing to note as well is that once we change the genetics, we can't change it back. Once we change it and then it's out in the environment and it's free to either cross-pollinate, or if it happens to be an animal, it can somehow breed with something else. For example, that salmon, if it were to breed with a natural variety, we can't then take it back. Then it's out there. So it's something to be aware of. And again, I think that's where the precautionary principle would come into effect really well. In terms of the health impacts, so these are the studies that we do know, and I'll just remind us again that it's actually quite limited. There hasn't been a lot of research done, and I think it's something that we still need to push for, that more and more research is done, because we don't know the long-term impacts, and we don't know multi-generational impacts of eating genetically modified foods. What we do know is there's an increase in immune cells that are involved in things like immune reactions, so allergies. And there's been a number of people who say that their allergies are worse every single year, or they're developing more food sensitivities or food intolerances. One of the things that obviously contributes as well to those food sensitivities and food allergies and intolerance is that we're starting to lose that biodiversity. So if we're eating processed foods, you might be eating corn and soy at every single meal. And so again, you're always hitting your body with the same type of proteins again and again and again, and that contributes to it as well. We see increases in inflammation. And inflammation, think of any condition that ends in itis, arthritis, hepatitis. Anything that ends in an itis would be an inflammatory condition. So we see an increase in that. We see problems with reproduction and vital organ damage when we're studying things like rodents who have been fed genetically modified foods. And we also see it through cattle and different types of animals like pigs and sheep who have been fed genetically modified foods. So we start to see that their organs show things like either inflammation or atrophy. And we start to see that their offspring might have lower birth weights, or that they might have fewer offspring, or that those offspring aren't as healthy when we compare it to other species that haven't been fed genetically modified foods. We have the creation of superbugs. So this would be bacteria that is antibiotic resistant. And this is something that's of particular concern. We don't want to create a situation where antibiotics no longer work for us. Because if they're necessary, then we need something that's able to stave off the infection. And we don't want to increase our resistance to that. And that's a very dangerous, slippery slope to go down if all of a sudden one day you might get a paper cut and it gets infected and you don't have something that can stop that infection. We do see some studies reporting an increased risk of cancer because of the alteration of DNA, that actually encourages your DNA to replicate in a faulty way. And then this is a question mark. There's no studies that I've found that have shown this, but it's just of my own particular concern, is when we're ingesting food that at the molecular level has been tampered with and has chemicals inserted into it, like Roundup resistance or this Bt soil bacterium, and the antibiotic resistant marker genes to go with it. When every single cell in that food that you're eating contains that at a molecular level, what does that do? And I would wonder what results would show for studies that would look at that.
I went to an open talk at Trent University that was organized by the Sustainable Agriculture Program, and they had a scientist come in who, I can't exactly remember his connection with genetically modified foods, but he was studying, what was that chemical called? Glyphosate.
Mm-hmm.
And his studies revealed connections to promotion or acceleration of autism.
Okay. So the comment was studies that show a connection between autism and glyphosate, which was that main ingredient in Roundup. So I'd love to get that person's name to look that up. Yeah. So one thing that I find really interesting too is labeling in and of itself. So when we poll Americans and Canadians, do you think there should be labeling of genetically modified foods? Again and again and again, it's always over 80% of Americans and Canadians will agree. Sometimes it's 94% of Canadians will agree that we should have labeling. So if the vast majority of people in our population and our nation want labeling, why isn't it done? You tell me. Money? Definitely. Politicians. And I love this photo of this little girl. I am not a science experiment. I think one of the biggest reasons why we don't have labeling and why they're pushing back so much against it is, for one, if we have the choice, we might not buy it, and that's going to affect their bottom line. So if you were to look at the back of your crackers and it said genetically modified canola, would you still buy it? Genetically modified corn, there was a sticker on it that said this product contains genetically modified ingredients. When I worked for Greenpeace, we used to have little stickers, and we would go into the grocery stores and we would stick things, this contains genetically modified corns, and we put the stickers on, and then we would watch, and people would pick it up and make a weird face and put it down and then buy the other one. So I think, interesting thing, it would affect their bottom line. But I think the other thing that's also important to consider is we no longer have a control group. So if we're all just getting slowly sicker, how do we know that it's genetically modified foods that are doing it if we no longer have anyone among us who hasn't consumed them at some point? They've essentially taken away any control group by introducing it to all of us without us having a choice in it.
Maybe we have to look at Europe, where I understand they banned GMOs.
So the European Union has labeling of genetically modified foods, and some countries within Europe actually have an outright ban. So Norway, Switzerland, these are countries where genetically modified ingredients aren't even allowed to move through and enter the borders. So for example, if you have a genetically modified food that needs to get into Italy, you have to go around Switzerland, you can't drive through it. So we do have lots of countries that don't allow it. And what I find really interesting is those same companies that produce things like Snickers, and they make a product that they can sell in Switzerland that has no genetically modified organisms, they will sell a version here that contains it. So we know that they can make it without it. So why don't we push these companies to do that? For solutions, though, I think we have a lot of solutions. In the meantime, I do think we should push for labeling. I think we should all have the right to make a choice whether or not we want to eat them or not. But in the meantime, we don't actually need them to be labeled as containing genetically modified ingredients, because we do know a number of examples where it tells us if they're in there or not. So we have something which is called the GMO project, and what they do is they will put a stamp on the back of a product if it doesn't contain any GMO organisms, so you can look them up. They also have an app for a smartphone, so you can go into a store, you can actually scan a barcode, and it will tell you whether or not that food contains genetically modified organisms. So if you're a techno whiz, or if you have kids that are into technology, I think it's a really interesting little tool to play with to start to learn which foods contain these ingredients and which don't. We also know that organic foods don't have any genetically modified organisms. As well, if you're consuming something like a dairy product, or if you're consuming a meat product, there's no GMOs anywhere in the chain. So you know that that cow couldn't have eaten genetically modified corn. It doesn't exist anywhere within the organic spectrum.
How about the seedless food, like watermelon, grapes, seedless?
If it's-
Are they GMO?
So the only foods that are GMO are the ones that we went through on the slides, the ones that are grown or the ones that we import. So there's no genetically modified watermelon right now or grapes. There is now an apple that will be on the market. It will be called the Arctic apple. It's been genetically engineered to not go brown, because I know that was we were all losing sleep at night because we couldn't just put lemon juice on an apple to prevent it going brown. We really needed that genetic modification. Yeah.
So how do we know that when we go into a grocery store that carries primarily regular, let's say, vegetables and fruit, that they stick a label on something that says organic? How do we even know that it is truly organic, but they just didn't stick a label on? Because I have heard people who work in grocery stores have been told to take the labels off of some foods, put them on the food because they ran out of organic stuff. It's just a label, they said. It's just a sticky label.
Yeah. So the question is, how do we know if it's organic in the store? So for things that are coming in boxes, it's not a sticker. It is within the packaging, so it's not something that you could peel away. In terms of when it's produce, if you have a grocer who is taking apples who are conventional and then just putting an organic sticker on it in order to charge more money, that's not allowed, and you should then report that, because that's not something that you're able to do, and I don't think that would be a fairly common practice. That is something that's regulated. There is also the barcode, so most produce that you're buying will have barcodes on it, and so you can see which is organic by the barcode on the SKU. I think one of the things that we can also do is to push our government to support the precautionary principle. When we're doing these big science experiments, we should do them first in a contained way and show that they're safe before we all become guinea pigs for them. The other thing that I think is important to know is what are the new GM crops that they're trying to push through? And one that they're trying to push through is genetically modified alfalfa. Alfalfa, again, is an open pollinated crop where insects carry the pollination very far. So this is one that I think we should be quite vocal in making sure that we don't allow this to go through. And Canada is also committing trials of genetically modified trees. Again, trees often have really big pollination areas, but trees are also things that live for a really long time. This is not a canola plant that has one life cycle and then spreads its pollen. Trees live for a very long time, and I don't think we want that type of long life with genetic modification before we know that it's okay to be out there in open trials. So those would be two that I would fight against.
I understand that the environmental working group publishes a list called the Dirty Dozen and the Clean 15. How do those lists relate to this topic, or if they do?
Yeah, so the question was the Environmental Working Group. It's a not-for-profit based in the US, and they're the ones that every year come up with the Dirty Dozen, Clean 15. So that looks at the chemical residue of pesticides and herbicides on produce. So what you end up having is a ranking from the most amount of pesticides to the least. Within that, again, we have very few crops that are genetically modified. So we have the papaya if it's come from Hawaii, crookneck squash, and then eventually we might have the apple. But because that's generally produce, there's generally less. So we're more talking about what's being grown in conventional farming in that sense. The Environmental Working Group does have another index that you can look up, which is food scores, which look at how much has this food been tampered with. So you can look up the Environmental Working Group food scores, and you end up getting a number. And the more, say, artificial components, so things like genetically modified organisms, but also are there artificial additives and are there synthetic ingredients in it? You can also use that as a score as well that would look at a broader amount of foods as well and give you a rating on it. Other things that we can do, and these are things that we could all do every day, is plant some of our native plants that end up feeding our pollinators. So we're seeing things like bees and monarchs and songbirds and amphibious life, their numbers go down. So let's support them by planting butterfly and bee-friendly gardens. We can not see certain crops as weeds, but instead see them as just a plant that maybe is growing in a spot that you don't want, and it might be really beneficial for you to pick it and eat it. So start to learn what foods around you are powerhouses of nutrition and which one of them might actually be powerful medicine. And so there's a lot of opportunities to do things like learn how to forage wild foods.